Chapter 13, Sample Problem Number 5. A frictionless cart of mass m is attached to a spring with spring constant k. When the cart is displaced from its rest position and released, it oscillates with a period tau that is given by tau is 2 pi root m over k. I'm not sure why they go with tau when most people go with t, but it doesn't matter. The graph of the position of this cart as a function of time is labeled Experiment A. Graphs for two other experiments that use different masses are shown below this. The same spring is used in all experiments, meaning that k is the same, even though we're changing m. So, in part A, we say compared to experiment A, in experiment B, the cart has twice as much mass, 4 times as much mass, 1/2, or 1/4, or the same. So, since we're looking here, we want to say what happens to the period. Getting the period requires going from place to place on a graph, like from, say, here to here, and figuring out how long that is. Doing that requires sort of getting in close, so let's zoom in a little bit, and we're going to go from here to here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It looks like the period is 11, which is a little surprising. If we look for B, it's going to be from here to here, and here we can at least play the game and say, oh wait, it's the same period. Since it's the same period, it's going to be the same mass. So we'll go back here and say it has the same mass. And then we now want to say compared to experiment A, experiment C, what happens? So we'll want to look at the period in C. And if we go down here, we can see, we zoom in and we see that we have the period for C. Well, one period in C is like here, and that is pretty clearly, it looks to be 1/2 the period. So now let's go back to our formulas and say T of C is 2 pi root mc over k, and then T of A was just 2 pi root ma over k. So this becomes 1 to 1/2. The 2 pi's cancel, which is nice, is where k's cancel, and we have the root of the mass of C over the mass of A. So 1/4 is the mass of C over the mass of A. So the mass of C is 1/4 the mass of A. And then finally, we want to say a fourth experiment D, the mass used in A is doubled, and the spring is replaced with constant spring constant K. So then the period would be, well, if we have doubled M, but we have also doubled K, then those two changes cancel out, and we get the same